Seems like some people might still be trickling in, but I think we'll go ahead and get started. So let me stop sharing this. Well, hi everyone. Hope everyone's doing well and has been staying safe. Thank you all so much for being here for our last workshop of the series, actually. My name is Sai. I've been working with a few other fellows here. We're also on the call for a NSF-funded project being conducted at Hubbard Burke Experimental Forest, and we created these seminars over the past couple of weeks to for students who are interested in or who are sort of maybe already pursuing careers related to ecology, environmental science, STEM, all those kinds of great things, to learn a little bit about different career trajectories and navigating the stage of your career from different scientists, researchers, ecologists, and to try and bridge that gap between students and scientists as well. So just to try and make those conversations a little more accessible for people. So thank you for joining us again. It's been really fun making these workshops. So thanks if you've tuned in for past workshops or if this is your first workshop, thank you for being here. Just a quick note, I think everyone probably got that notification, but when this session will be recorded, and for people who weren't able to join, or if there's anything you'd like to look back on, and all of those workshops will be or have already been posted to a YouTube channel, and I'll drop the link for that in the chat as well for anyone who's interested. So for our last workshop today, we're joined by Dr. Lindsay Rustad. Dr. Rustad is a research ecologist for the USDA Forest Service, the co-director of the USDA Northeastern Climate Hub, and team leader at the Hubbard Burke Experimental Forest located in the White Mountains of New Hampshire. So thank you so much for being here, Dr. Rustad. We'll pass it over to her shortly. We're also joined by our mentor, Dr. Andrew Ryman, who had the awesome idea of putting together these workshops. And if I'm not forgetting anything, I'll pass it over to Lavina.
Hi, everyone. My name is Lavina. I'm a postgrad student at Hunter studying the GIS certificate program. I'm also one of the fellows working in this research/workshop series. I would just like to ask everyone to briefly put your name, your preferred pronouns, institution, and major, if applicable, in the chat box, just so that we're familiar with who you are and where you're coming from. I'll give you a minute to do so before handing it over to Jean.
Hi everyone, my name is Jean Zion. I'm currently a junior at Hunter College and doing my environmental science major with a minor in comp sci. I'm really excited for today. Today will be our last workshop, sadly. And today, so we will basically go through, Lindsay will talk about her trajectory into her career and more about her work at the Hubbard Burke Experimental Forest, which I heard is beautiful. And throughout the presentation, please feel free to ask questions in the chat, and we will hopefully have some time for a Q&A later on. And that'll be all. Lindsay, you're free to.
Okay, so I'll take myself off of mute, and it's great to be here today, and thanks everybody for showing up at noon. I am going to share my screen, so bear with me for just a minute while I adjust my technology. And could somebody nod if my screen is up? Yep. Okay, great. So wait, let me just move something here. Okay, hang on. Let me just. Okay, so I am Lindsay Rustad, and I am a forest ecologist with the USDA Forest Service. I'm also the team leader for the Hubbard Burke Experimental Forest, and you're going to hear lots about that today. I have actually spent the greater part of, it's kind of scary to say, but the past 40 years trying to understand what makes forests tick, and particularly how they respond to and recover from large-scale disturbances like air pollution, climate change, and extreme weather events. So I have the title of my talk here, which is Reflections on Navigating a Career in Environmental Science. And I guess once you've been doing this for a couple decades, you can have titles of talks called Reflections. So what I want to do today in the next 20 minutes or so is share with you my story on how I navigated this lifelong career, including a little bit about my non-traditional background, how and why I made some of the twists and turns that I took, the people that I met, and then some of the lessons that I learned along the way. So again, research ecologist with USDA Forest Service. And I have to tell you, on most days, I think that I have the very, very best job in the whole wide world. I get to work at one of the most famous watershed study sites. I get to do crazy experiments like making our own winter weather events. I get to rub elbows with world-class scientists, and I even get to share the forest and occasionally the stage with artists. But it wasn't always that way. I started out as one of those odd ducks who studied liberal arts. I did my undergrad degree in philosophy at Cornell University in New York State, and I spent a lot of time with the works of Plato and Aristotle and my favorite, Marcus Aurelius. However, contrary to some opinion, this was not a dead end, but rather it taught me the art of logic and the trick to take a problem apart and look through it, under it, or over it for an answer. And of course, in philosophy and in many of the liberal arts, there often is never a right answer. And so when I had to take a science class to fulfill a distribution requirement, I was overjoyed to find out there was a right and sometimes a wrong answer to things like true, false questions, multiple choice, and even fill in the blank questions. And I got to take all kinds of natural science classes about birds and streams and forests. And all of these piqued my curiosity about the natural world. I was even more excited to find out that I could combine my interest in the natural sciences with my passion for the outdoors. I was a girl from the suburbs, actually from Port Jefferson on Long Island, not far from where you guys are now. But my love was often for the mountain streams and lakes, especially the Adirondack Mountains of upstate New York. When I graduated from Cornell with that very useful degree in philosophy, all I wanted to do was spend a full year up in the Adirondack Mountains, watch the seasons go by, and honestly, I wanted to just be a woodswoman. In fact, this book that you can see here was entitled Woodswoman. It was my favorite book, still is. It was written by Anne LaBastille, and it was about a woman who went off in the Adirondack Mountains of New York and lived on her own for a couple of years. So, Woodswoman, Anne LaBastille. So as it turns out, with a lot of serendipity, which of course means chance, I landed a job as a field technician on an acid rain project focused on 3 lakes in the very Adirondack Mountains that I loved so much. And I landed that job because, one, of a chance encounter with one of the project leaders, a man named George Henry at Brookhaven National Laboratory. And 2, the fact that I volunteered to work for free as an intern, which we were allowed to do back then. So this is a photo of me back in 1980. That was our field vehicle, an old Jeep at the time, and that was our field lab and house where we all lived to do our work. In case you haven't heard of it, acid rain refers to rainfall made acidic by air pollution, typically by the burning of fossil fuels. So instead of having a neutral pH, acid rain can be as acidic as even lemon juice. And in the 1980s, we knew that acid rain could be harmful to forests and fish, but we had to figure out how. My job was very simple. It was to wash sample bottles and to hike into 3 remote lakes to collect water samples. And I got to tell you, for me, it was perfect at the time. I had never taken a course in chemistry, But on the job, I soon learned things like pH and alkalinity, the anion, sulfate and nitrate, the cations, calcium and magnesium, the many shades of dissolved organic carbon, and a mysterious metal called aluminum. I also met some of the luminaries in our field out on those remote lakes. Jim Galloway, here on the left, is clearly pondering something important. And here's Jamie Shanley, who now works at USGS on the right. He was fussing over one of the early automated water samplers that he fondly dubbed Tubby. I also met people like Pete Murdoch, Charlie Driscoll, Chris Cronin, Dick Wright, and Jack Cosby, some of whom you may have read about in your papers. This acid rain project turned out to be a who's who of forest ecology, which was great because I got to meet them all. And Jim Galloway, who I just showed you, ended up hiring me and actually paying me. And he invited me back to the University of Virginia, where he taught, where I spent a month working at the famous White Oak Run Watershed in the Blue Ridge Mountains. And I learned all about how to measure stream flow and about watershed inputs and outputs. And serendipitously, you can see this is one of my favorite words, Jim Galloway introduced me to a fellow philosopher scientist, a man named Herb Borman, who happened to be on sabbatical from the Yale School of the Environment to the University of Virginia when I visited. And Herb spoke to me about a mystical place called Hubbard Brook in another set of mountains in New Hampshire. And in fact, acid rain, which is what we were studying in the Adirondack Mountains, had been first discovered at this place called Hubbard Brook. And Herb encouraged me to apply to the Yale School of the Environment. And once accepted, I left my hermit home in the Adirondacks and I went to the city, New Haven, to learn about the forest. And it was there that I buckled down to catch up on foundational knowledge of water, watersheds, and ecosystems. And in addition to Herb Borman, I met the likes of Gene Likens, Tom Sycamore, Garth Voigt, giants in the field of environmental science. And as a student, we took field trips up to that magical place I had heard about called the Hubbard Brook Experimental Forest. And for those of you who don't know about it, Hubbard Brook is an 8,000-acre forested valley located in the White Mountains of New Hampshire. It was established by the Forest Service back in 1955 to study water for the region, and it has since grown to be one of the longest continuously running, perhaps most comprehensive ecosystem study sites in the world. And it was there that I had that epiphany of understanding that because forest soils, climate, and geology change slowly, right, over decades to century to millennia to longer, that it was important to conduct long-term studies, at least on the scale of decades, to one, make these long-term changes seen, and two, to understand the normal conditions are like so we can recognize when something is not normal, is extreme, or is just plain strange. So at Hubbard Brook, I also learned about the small watershed approach, which was pioneered there by Herb Borman, Gene Likens, Bob Pierce, and Noy Johnson. And what an amazing concept it is. It basically considers the watersheds at Hubbard Brook to be like a measuring cup. It assumes that they're underlain by a solid layer called bedrock, such that everything that's poured into them will fill them up and eventually pour out. And then if you measure everything that goes into them, say in precipitation, and everything that goes out of them, say in stream water, and you analyze the chemistry of that water, you can multiply the two together and create whole watershed scale nutrient budgets. It is simple, elegant, and powerful. And even more amazing, you can use this method to do whole watershed scale experiments. And that's exactly what they had done at Hubbard Brook. So holy moly, they started in 1965 and they cut down the forest in a whole watershed. They herbicided it for an additional 2 years and they left it to regrow. Think about cutting down all the trees in Central Park, herbiciding it for 2 years and watching it regrow. Absolutely astounding and amazing. So in that study, they learned many things, but 3 stand out. first of all, stream flow increased by almost 50% during the 3 years of the treatments. 2, nutrients like nitrogen increased by up to 50 times in stream water during this same period. And 3, the ecosystems recovered relatively quickly when the forests were allowed to grow back. They went on to do more of these world famous whole watershed experiments. Here you can see the original cut on the right. Then there was a strip cut in the middle, and then there was a third whole tree harvest on the left. And the results from the second 2 experiments reinforced what they had learned from the first, including this concept that nature is resilient. So now, don't shudder, okay? But this is the periodic table of the elements. And actually, I have grown to love this table, particularly the many colored boxes of the elements. So when I was at Hubbard Brook in the 1980s, which was the heyday of acid rain, there was a lot of research focused on these elements. Up here in the far left, hydrogen, because it causes acidity. Then over here are nitrogen and sulfur, because they turn into nitric and sulfuric acid. Then over here on the left are the base cations, calcium and magnesium, because they're important plant nutrients and they neutralize acidity. And then over here in the purple square is that mysterious metal called aluminum. So aluminum, my favorite element, has an atomic number of 13, an atomic weight of almost 27, and has a property that at low pHs, like what happens under acid rain, it has a +3 charge. And this makes it chemically sticky, reactive, and toxic to fish and plants. So at Yale, I worked with Tom Sickema on the relationship between soil aluminum, a root rot fungus, and tree health. And I also worked with the legendary Gene Likens on the close association between aluminum and carbon in the tributaries of the Hubbard Brook. When I was ready to do my PhD, the acid rain spotlight was now fully on aluminum. And I did my dissertation with Chris Cronin at the University of Maine on the aluminum biogeochemistry project. And my job was to better understand the biological cycling of aluminum. And I chose to do my work in a red spruce forest in Maine, where I set up my own mini watershed study in the slopes of Tunk Mountain. And I learned how truly sticky aluminum was in soils and plants, and how tightly this element was retained in the landscape. It was kind of like glitter, right? You get it on your hands and it sticks to you through static electricity, and you just can't kind of shake it off. Meanwhile, the aluminum biogeochemistry project called Albios was also my first exposure to being part of a large international multi-investigator, multi-site study. And I was intrigued by the power of doing studies across not only time, like we had done at Hubbard Brook, but also space. But before I go on, I have to admit there was a darker side to these years. So I started out in philosophy, and I felt I was at a disadvantage, especially compared to all these truly amazing grad students, postdocs, and senior scientists that I was meeting. And I didn't think I could ever be as good as them. And I was suffering a significant case of imposter syndrome, though we didn't know the word back then. And this led to anxiety, to stress, and to an eating disorder. But I think of myself as one of the lucky ones because I got professional help and I was able to overcome it. But my message to all you folks out there is you're not alone. If you're having problems, you're undergoing stress, and there are good resources available if you're struggling. Never, ever, ever be afraid to ask for help, and never, never, ever shy away from giving help if asked. So where was I? I was back in the 80s and we were tackling problems. So we were tackling the acid rain problem in the late 80s, but we were also recognizing another environmental problem, and that was nitrogen. So nitrogen has an atomic number of 7 and an atomic weight of 14. In forests, it has a peculiar property that if there's too little nitrogen, plants are undernourished and they don't grow very well. But if there's too much nitrogen, then the nutrition of plants gets out of whack, and trees also don't grow very well. So too little is bad and too much might be worse. So as we were learning that increased nitrogen in air pollution, that is acid rain, was adding too much nitrogen to our forests. And great thinkers like John Aber were sounding the alarm. And there was a new wave of research to understand this emerging phenomena that we were calling nitrogen saturation. And I became a part of this new wave of research. As I was finishing my PhD in aluminum, I joined another large interdisciplinary team of scientists led by the University of Maine researchers Steve Norton, Ivan Fernandez, and Steve Call, who were starting the Watershed Manipulation Project at the Bear Brook Watershed in Maine. And the Bear Brook Watershed in Maine is a long-term paired watershed study, similar to those I'd learned about at Hubbard Brook, that was designed to study the evolution of acidification and nitrogen saturation of a forested watershed in Maine. And so in a nutshell, we added a small amount of nitrogen sulfur by helicopter to one watershed every other month, beginning in 1989 and continuing for 26 years through 2016. The adjacent watershed served as what we called the reference for the control. And results from this study have helped refine our understanding of how forests respond to nitrogen and sulfur deposition and have informed air pollution policy both here in the US as well as around the world. So now it's the early 1990s. We're still working on acid rain and nitrogen saturation, but we're eyeing the steady rise in atmospheric carbon dioxide concentrations. And we're beginning to understand the links between heat trapping gases like carbon dioxide and a warming climate. So Ivan Fernandez and I established one of the early soil warming experiments in the spruce fir forest in Howland, Maine. And we put several miles of heating cable into the forest floor of two large plot. It wasn't a watershed study, but it was a large plot experiment addressing how forests respond to warming. And in this study, we learned how warming the soil significantly changed carbon and nitrogen cycling, particularly through increased rates of processes like soil respiration, nitrogen mineralization, and litter decomposition. By the late 1990s, there was literally a worldwide explosion of global change experiments. And through some serendipitous encounters, a group of us met, and I had the opportunity to lead the establishment of an international research coordination network called TERAC, or Terrestrial Ecosystem Response to Atmospheric and Climatic Change. And the goals of TERAC were rather simple. They were, one, to synthesize the results from all these hundreds of experiments, and two, to bring people together from around the world to coordinate these efforts. And over nearly 2 decades, the network sponsored workshops all around the world, built communication tools like websites and newsletters. We didn't have social media at the time. 3, helped train a new generation of global change scientists, including finally a growing cohort of women in STEM. And we published over 50 papers. The greatest value of this network, however, was bringing together the global change community of scientists working from all over the world. It was an exciting time, and I have to say I met and made friends with many men and women from all over the world. So in the mid-1990s, although still working in Bear Brook, the Soil Warming Project, and running TERAC, I made the move to work as a research ecologist at the Hubbard Brook Experimental Forest. And in the mid-2000s, I became the team leader for the forest. Who would have thunk it, back when I was doing my graduate work there in the 80s. So for someone who had been studying forest ecology for a decade like me, it was then, and it is now, a dream job. At Hubbard Brook, I've had the opportunity to be a steward for one of the longest continuously running ecosystem studies in the world, and I get to work almost daily with data from our long-term monitoring programs. I've also been able to continue to work on our long-term watershed scale experiments, as well as conduct new experiments on forest drought, warming, extreme weather events like ice storms, and now the Hubbard Brook nitrogen oligotrophication, or the HBNO experiment. And so my job is filled with people. And I think it's people where the magic of science happens. And here's a shout out to the literally hundreds of people that have made Hubbard Brooks such a success, from the students to staff to scientists to volunteers to visitors. Here's an image on the right of celebrating 60. I thought it was my 60th birthday at the time, but it turned out to be the 60th anniversary of Hubbard Brook. But anyway, it gives an image of some of the folks at Hubbard Brook. So that's a full circle of my career so far, and I certainly hope there's a lot more to come. But I'd like to end by reflecting on some of the lessons I've learned over these past decades. So my thoughts on science. The first is progression. And that's the progression of science can be slow, or it can come in fits and starts. You have to be patient. 2, building blocks. Building blocks matter, right? Laid one on top of each other, one by one by one. Yours may not seem significant on its own, but the whole is indeed greater than the sum of the parts. 3, think across disciplines. Discoveries are often made at the interfaces of disciplines. 4, think outside the box. That's usually where the big ideas are. And 5, don't be afraid to think big. Consider your ideas first, dream about the best way to approach it, and then figure out how to make it happen. So some thoughts on people of science. 1, of course, embrace diversity of all kinds, even of the intellectual background like us poor philosophy misfits. 2, be inclusive, be kind. You don't know what others around you are going through or suffering from, and you never know where those next big ideas are coming from. And 3, encourage and take advantage of planned and chance encounters. Many of us, myself included, are introverts, but push yourself to meet people even now on Zoom. You never know who you're going to meet, and you never know what ideas they will have or what wild ideas they will spark in yourself. And finally, thoughts on the pursuit of science. And the first one, of course, is stick to it. There are going to be ups and downs. Budgets will be good and bad. Administrations will come and go. You're going to get through it. Just don't give up. 2, life events, right? We all have life events. We have births and deaths and marriages and divorces, time for caregiving of young and old. Try to balance these with your pursuit of science. Give them the time they need, the time they deserve. When you die, you will not likely regret a sample you did not take, but you might regret a loved one you did not see. 3, expect trouble. There may be illness, addictions, recoveries. Never fear asking for help. Again, you're not alone, and never hesitate to give help when asked. 4, recharge. Some of us, again, like myself, are workaholics and we're go all the time. I've learned to take a break, recharge, empty my brain. And when I come back is almost always when I have the most new ideas. 5, closed doors and glass ceilings. We've all heard about those. You may have come across doors that you think are closed, or maybe that glass ceiling. Don't accept it. Look for a way through, around, under, over. Keep at it for yourself and also for those that will follow you. And finally, be open and welcome to my favorite word, chance and serendipity. You never quite know what's around the corner, what's going to fall into your lap or suddenly appear before you. Be open to changing course if that happens. Allow for spontaneity and embrace the unexpected. I'm going to switch gears for just a minute with a final thought. And if you were keeping track, you may have noted that I mentioned many men that were influential in my journey. I never had a mentor, let alone a female mentor or a mom mentor, which is probably what I would have wanted most. How do you have a career and be a mom? It was a bit of a mystery to me. And in fact, it was rather lonely at times. As a good friend and colleague of mine, Dr. Mary Beth Adams, on the left here, said in a recent tweet, there were so few women in forest soils in the old days, but we were a team. And we stuck together, supported each other, and always lent a hand to the next woman or girl or guy coming through the door. But I'm happy to say that times have changed, and there are now many, many more women in STEM, single women, married women, women of all races, women with kids, women who choose not to have kids. There are lots more women to be role models and mentors for those to come. So all of you, right, can be people of science and lead the ranks of your generation of STEM pioneers and help solve your generation of environmental problems, some of which perhaps we bequeath to you, and hopefully change the world for the better. The pursuit of science, I think, is an amazing calling. So thanks for listening to my journey, and best of luck in yours. And with that, I'll stop sharing. That's my story, and I'm sticking to it.
Thank you so much, Lindsay. It was really, really awesome to hear from you. For now, I guess we'll open it up for a Q&A. If anyone has any questions, feel free to unmute or drop them in the chat. And we'll definitely make sure to get to those in the next 20 minutes or so. And then we'll end with a couple of closing announcements and statements. Now, I have a quick question. We had a really great conversation with Dr. Templer few weeks ago about imposter syndrome, and I'm really glad that that was like a part of your presentation and your slide. I was wondering whether, maybe not, maybe none come to mind, but if you had any like specific scenarios or situations early in your career, having just graduated with your bachelor's in philosophy, if you had any like sort of specific circumstances where you felt those feelings starting to trickle in. Maybe there wasn't a name for it before the way there is now, and we can really identify it before, but where you sort of felt those imposter syndrome like feelings start to come in, and how maybe you navigated that.
Oh, it was very difficult. I mean, to be honest. And again, I didn't have a lot of people to talk to or share that idea with, and there was no name for it. So it was just feeling you never feel good enough, right? You never feel smart enough, you never feel witty enough. And again, I was surrounded by, just some of the, the best of the best, these just amazing people that I had the honor to work with. And, for me, it led to stress and anxiety and an eating disorder. And I did have to find professional help. And I feel so lucky that I found someone in the 1980s who was able to help me through that. So I have so much empathy, for people who are going through that now. And, it's just know that you're not alone, that other people have these feelings, and reflect, that you are who you are and what you have to give. And if other people don't like it, too bad, but that's what you got. But I will say I'm really glad that it is brought up, and it's not unique to women. It's men, women, older folk. I still have it sometimes, right? I still have it sometimes, right? I have Andy sitting next to me, and he's brilliant and amazing, and it's great to work with all these people. But you have to be tough, or think tough.
Yeah, I'll just add that the tricky thing is, well, it was encouraging through this workshop series to hear that everyone's had imposter syndrome at some point, and maybe continues to. And for me, like pretty early in my career, I remember at each stage of my career, like, all right, once I get my master's, maybe imposter syndrome will go away. Once I get my PhD, it'll go away. Once I land a faculty position, it'll go away. And it's never gone away. And you'll always find someone that's published more papers, gotten more grants or something along those lines. And it's easy to kind of like beat yourself up too much or get down on yourself for not being like productive enough. And I don't have yet a very good way of always dealing with that. And I don't know, Lindsay, if you have come up with any, I don't know, like mental health approaches, like when that imposter syndrome starts to creep in and eating you up a little bit, if there are certain things that you've come to realize you can reliably do to, push that aside and think a little bit more clearly. I know there's a mix of undergraduates and graduate students here and some faculty members, so I'm sure we can all, gain some wisdom from that.
I honestly think for me, it helped a lot to be able to name it, right? So when I had and have those feelings, I can say, oh, I get it. This is the imposter syndrome coming up. So for me, it helps to be able to name it. And then somewhere along the way, I just learned, that shrug my shoulders, right? I am who I am. And I know I give my best and I give my all, and that's all I got. So as long as I know in my heart of heart that I'm doing the best I can at this particular point in time, then I'm okay with this. And this particular point in time may change, because if, that point in time when I just had a child, was a different level of productivity than later on, when I was caring, for an elderly loved one, that was a different point of time. So I think the biggest thing is learning to be kind to yourself, right? Give yourself a break.
I have another quick question. So you mentioned that interdisciplinarity being really important. I remember Dr. Groffman said something about how we should avoid disciplinary chauvinism, is I think the term he used in environmental science. And I know at Hubbard, Burke, I believe you're working on something like relating art and science. And we were talking about this last week. It was like a nice conversation about combining art and science. I don't know if you could talk a little bit about the work that you're doing there.
Sure. So throughout my career, I've worked across disciplines. When I started out, I think disciplines were more stovepipe, geologists and hydrologists and physiologists. And, through the course of my career, we kind of developed this field of biogeochemistry, right? Where many disciplines were really working together. And even when I did the research coordination networks, that was bringing people from different disciplines and different backgrounds together. So it's something that I've always found very enriching in my work. And over the last decade, I've kind of expanded the boundaries to work even further afield, working with artists, working with musicians. And what I find so gratifying on this is I've learned so much from them. And if you think about it, if we have a common problem, right? So I don't know, stream flow coming or, water coming from a seep at Hubbard Brook and going into stream flow. We're all kind of trying to figure out how it works. Well, when I'm in the woods with artists, sometimes they think about things in a completely different way, kind of through a different lens. And sometimes it's very eye-opening to me that I realize I didn't really understand something quite as well as I thought I did. And they have some really unique views on things. So that's one thing, just pure science, just sharing, trying to understand the forest, from these different lenses. And then the other part of it is, they have an ability to communicate our science to a broader audience with more empathy. Right, I can write, as many, papers, well, not as many as I should, but I write a lot of papers, but they're a little dry. No offense to the science, and some people will read them, but when I work with an artist and say we created the water viz, where we take real-time data and we turn it into animated digital art in a forest symphony. well, people get really engaged. They want to listen to our data, they want to see it, and they want to learn more about it. So it's also a way to engage with a broader audience, to have people have more curiosity about what we're doing, and in some cases have more empathy. And some of you who've heard me talk is I really do believe in this kind of facts to action continuum. And it's basically, we scientists live in the world of creating facts, right? And understanding from those facts. But it's really the arts and the scientists that create empathy from the understanding, and it's empathy that creates action. So sometimes we scientists get very frustrated that no one listens to us, right? We've been talking about climate change for several decades now, and we have all the facts and understanding, at our fingertips, but we don't always convey the empathy. And it's the empathy that's needed for action. And I ramble on, but I will anyway. Just as an example, think back to Rachel Carson, right? Another person who was influential, in my life in writing Silent Spring. So we knew a lot about the toxicology of pesticides, but it was her work, right, that incited people's, imagination and empathy that led to the banning of DDT and other elements. Think about acid rain. We had all the science, we had all the facts, but perhaps it was the images of the dead fish, the dying forest, and particularly the melting tombstones, that really got people, for action. I'm not sure what the empathy is yet for climate change, but we're working on it. But artists, and when I say artists, I mean writ large, right? I mean artists, musicians, writers, philosophers, that help us translate our knowledge. So it's incredibly rewarding to work across the disciplines of arts and sciences. And again, I just have learned so much, and it's enriched my work so much.
That was great. I would love to add like one additional thing. I've always been so inspired every year, Lindsay, when you talk about the different mergers of arts and science at Hubbard Brook. And in the time that I've been teaching at Hunter College, while I teach science classes, we often get people from arts backgrounds or policy backgrounds, much different than the sciences. And earlier this week in class, we were talking about sort of the scientific process, and really like the first step of that is just observing things, right? That's how we come up with our questions. And what I've just found so rewarding working with this wide range of students is how different sort of like academic backgrounds and life experiences totally change the way people might observe the same exact thing. And by interacting with and working with people of all different academic and life experience backgrounds, I think we're able to do science a lot better because it helps us to think outside the box and observe things in the multiple different ways that we need to observe them to really move science forward.
I'm like amazed that I stumbled on this workshop series because I asked the question last time about the art because I had an art degree from an art school in Portland, Oregon, before I moved to New York. And I've had and still have imposter syndrome. And I'm just like terrified. I'm so scared of how to transition from one field to another, because I've met so many people who are just all about like the pure science. You know what I mean? There's like a lot of gatekeeping where it's all about like how pure and how, non-political and not pushy you are with your data and with like your findings. Like everything has to be like super, super neutral. I feel like why aren't we moving towards giving our like professional opinion pushing it a little bit harder these days? Like, where do we belong there? Like, where are the people who are supposed to, I feel like with policy, because I interned at the EPA before I started school, and I've never seen a slower, more inefficient way to do things, to go about, even cleanups. Like I
I wonder where people and where scientists these days kind of belong in the discussion of climate change and like all the problems facing us right now.
Well, I'm just going to tackle something on that. Thank you for speaking up. It's really great to hear from you. Again, I can talk about reflections from, several decades of doing this. And I do think that at least the environmental sciences are much more open to, multidisciplinary thinking and embracing some of these other ways to see the world, as Andy was talking about, and to translate. So we're celebrating versus hiding, those other sides of ourselves. And one example I would give you is, before COVID, we all went to professional meetings, Soil Science Society of America, Ecological Society of America, Geological, all the societies. And it used to be very stovepiped, right? But now in not almost in all of these, there are sessions integrating art and science. So there's a much greater, appreciation and celebration of some of these broader approaches to tackling some of these really hard multidisciplinary problems that face us. So I saw a note from Andy of emerging disciplines, not transitioning. And I think it's just fantastic to bring people with different backgrounds to bear on a common problem.
What have you heard of? So I thought my bright idea that I came up with merging my two degrees, because I just got my environmental science degree from Queens College. Thanks. And I was hoping to maybe merge the two in landscape architecture. And I'm wondering, landscape architecture, I feel like is at this new point where they are starting to really look at ecological restoration and more large, more holistic thinking. Do you yourself see more of that out there in the field?
I really do. I really do. And another example, again, Andy's in the square next to me, so I keep pointing at the square. It's probably not on your Zoom, but so we have a project that just got funded, some seed funding called Your Forest, Your Health. And this is a project that's bringing together, biogeochemists and technically savvy people who understand all about environmental sensors, as well as people from the public health community, both in the US and in Canada, kind of trying to merge these fields. So trying to understand how we manage forests, not just for the usual ecosystem services that we think about, clean air, clean water, food, fiber, biodiversity, all those really great things, but also for human health. So it is thinking about the feedback to what we do, how we manage our ecosystems, and then what they also provide for us, as well as another sphere of understanding that they have value just unto themselves, not just the value they, the services they provide us. So I feel like I see a lot of movement, across disciplines.
That's so positive to hear. That makes me so happy. Thank you so much.
I'll add one small piece for folks who maybe are artists or art inclined and also interested in environmental science. The National Science Foundation has this program, Research Experience for Undergraduates, which is really an amazing opportunity for undergraduates to be involved in a very immersive, hands-on way in research. One of probably the most storied programs for RU is at Harvard Forest in Massachusetts. They've been doing it for decades. It's a really amazing opportunity. Some of our students have participated in it before. And a few of the years that I've gotten to interact with some of these students, they've also had artists as art students as members of their REU cohort. So while we traditionally think of that program as being for people pursuing degrees in science, I thought it was really interesting the way that they brought in art majors into this, and those art students spent time with each of the science students on the field research projects they were working on, and they came up with their own way to come up with like artistic representations of that research. And so at all different levels of training, there are these opportunities, and increasingly so in ecology and environmental science, of trying to merge different fields. I think like we all collectively know that A, it helps to improve the science, and B, in such a societally relevant STEM field, it's really important in helping to communicate that science. So there's lots of different ways to integrate art and science. Maybe while others are thinking of questions, Lindsay, can I ask you a question?
Sure.
So I love always how optimistic and positive you are, and I think that's also been a common theme in a lot of these talks. And you know, we're a little bit different in our age and the timing of when we started our academic trajectories. And so for me, I've never had a male primary advisor. I've only ever worked with women, and most of my friends in the cohorts that I've been in, my peers, have largely been women. So it seems like there's been this big shift maybe between when you were pursuing your degrees and now. And I was wondering if you did this a little bit in your talk, but maybe to kind of keep with that positive theme, reflect a little bit on how you think you've seen fields of ecology and environmental science change, you know, I guess from going from a largely white male dominated field to being more diverse now. What has that looked like to you being in this a bit longer? And what do you feel like, or what do you see as challenges and opportunities to kind of keep that going moving forward?
Oh, that's a big question. So, you know, I was always so focused on what I was doing, and that was kind of the status quo. So, you know, those early decades, I didn't really, you know, think about the diversity, and we didn't have a national conversation on diversity, equity, and inclusion. That wasn't part of it. You know, maybe by the time we got into the, you know, early 2000s, you know, NSF in particularly was, you know, really, you know, promoting, you know, recognizing diversity, you know, of gender, of race, you know, of of people, and you know, we were trying to, you know, promote this in the early 2000s. Early meetings at Hubbard Brook, we always do a count, right? You know, of different people. It was about a quarter women, and now it's easily, you know, half and half. So it's been it really has been an evolution. Again, thinking of diversity and enrichment of thinking. You know, I think diversity of backgrounds, you know, brings a richer fabric to the conversation and is way more inclusive, right? So, you know, I would hope that, you know, students coming from different backgrounds, you know, have role models, you know, have the ability to embrace, you know, our universal diversity. So it's been, you know, you talk about being optimistic, right? You know, so some people on my team call me Pollyanna, but you know, that's beside the point. But it's been a really positive thing. So some people go on in their career and right, they get jaded and grumpy. You know, I think things just keep getting better in terms of the science. The problems that we face are equally weighty and serious, which is why we're all here, right? But I think the cadre of the scientific community, the fiber, the background is stronger than it's ever been.
I have one last question, just out of like sheer curiosity. I was wondering, I know you mentioned you took those science classes in undergrad, but was there like a specific moment for you where you knew you wanted to transition to a career in environmental science? Was there anything that specific that drew you to it? Did you already know? And you just kind of
Birds. It's all about birds. I love birds. I wanted to be an ornithologist. So I took the biology and I realized I could take ornithology and then I would have a laboratory where I got out to go out into the woods and look at birds. That was it. But then I realized there were very few jobs in ornithology, right? So I decided I'd be a forest ecologist because there are so many jobs in forest ecology.
I just want to follow up on one of the points raised here. So Lindsay, early on in your talk, you mentioned that one of your first exposures to doing ecological research was sort of an unpaid internship in the Adirondacks, right? And you know, over the last couple of decades, maybe for a lot of people, that was like their first sort of experience into research. And at the same time, that creates barriers for who can be involved in research, right? You need to hopefully be in a situation where you can, you know, take a volunteer position. And I'm wondering if you have thoughts now on places where people who might be interested in getting hands-on research experience, but can't do it for free or can't necessarily travel to the many remote field research sites where a lot of this work is conducted. You know, what are some ideas or thoughts that you might have for how those students can get engaged in research? These are conversations we have a lot at CUNY. I offer my perspective sometimes, but I would love to hear your thoughts on this.
Yeah, that's a really good, you know, question. I think the volunteer, you know, unpaid is probably a thing of the past because we're much more cognizant of not taking advantage, you know, of people's goodwill. But sometimes these volunteer opportunities are there, but you know, they're not very well paid. You know, so one thing is recognizing, you know, the value of what you're getting out of it. And, you know, it might not be the same job as you would have in Silicon Valley, right, as a coding engineer. But so that's one thing. And then the other thing that I didn't do, but I've seen a lot of students and younger people do successfully is getting involved in local organizations. You know, up here in Maine, which is where I live, you know, we have very active, you know, Trout Unlimited, you know, just as an example. If you love the outdoors and you love aquatic sciences and fisheries, you know, being involved in, you know, Trout Unlimited, or, you know, your local conservation societies, or, you know, the local parks or forests. So, you know, I think I hope there are some opportunities to get involved with like-minded people. I wish there was more opportunities for paid internships, which is, I think, more, you know, what you were talking about. We all try to sponsor them and write them into our grants, you know, every time we can. But I think that would be a good message for the funding agencies, that these experiences are incredibly valuable to building, you know, our next generation STEM workforce.
Maybe while we're on that topic, like we have a big group here today. Maybe some of you have been to our other workshops, and I'd be curious to know, you know, have these workshops, and I'm certain Lindsay's talk is on the top of the list, but have these workshops been helpful in helping you to think about how to potentially navigate a career related to ecology and environmental science? And do you have any sort of outstanding questions or concerns about like how you can fit into that field, or how you might start pursuing that field, or if you're, just about to graduate and you didn't major in anything related to science, how you might go about making that jump, right? Lindsay's a great example of that. So sadly, this is our last segment of this workshop series, but maybe with the last few minutes, I would like to encourage anyone who's on here to speak to any of those points, voice concerns, questions, type them in the chat. I think it would be great to have a brief conversation about that.
I myself am wondering about grad school and applications to grad school and how they kind of filter through people without a related, like directly related background to the grad program that we would be applying to. That scares me so much. Like I have a deep fear of just being rejected from like my most like the programs that I really, really want to get into because I don't have, like a landscape architecture bachelor's or something like that. I mean, I'm sure that it'll be okay, but for other people who have even, like a psychology degree or something like that, it's kind of scary. It's very daunting. And the competition these days is definitely different. Every year it gets harder and harder. How do we overcome that?
Good afternoon, everyone. This is Dawn Roberts-Sample. I'm an assistant professor at York College. My area of specialization is environmental science. Now, I'm not sure I can speak specifically to your question and your discipline, Adriana, but I've experienced some of what you mentioned, some of your concerns. I think that students need to do some homework before they apply to institutions for graduate work. So knowing who the professors are and what their fields of research are and whether there is funding. I think funding is so important. Whether what they're doing at the time is something, and this would be for individual professors, whether those are the things you are interested in, and make direct contact with them. Because sometimes professors are looking for students and they just don't know who might be interested. So, and this was actually my experience. I came to this country after starting my graduate work, and I just reached out to a couple of universities. Luckily, Rutgers University, with open arms, embraced what I wanted to do. And my chair at the time, Dr. Alexander Gates, just advised me to go around the department and speak with professors, just ask them, let them know what I'm interested in, and then see if that's something they'll be interested in too. And luckily we connected. 3.5 years later, I graduated with my PhD. So sometimes there are programs and there is a lot of funding. Some universities are more endowed than others, but there is funding from NSF, NIH. I was a beneficiary of both of those. And the professors are really hoping that there'll be students who will connect with them and they'll be happy that they can conduct research with the funding that's available. I was literally told, don't leave, we need students who are interested in this field. So it's just a matter of speaking. I think having that conversation with your professors is so important. You don't know where you may land. The funding might just be there and ready for you to start your research.
Yeah, I think that is really great advice. And I know when I'm looking for a PhD student and I'll get applications from people, like typically in a lot of the sciences, you would reach out to a particular faculty member that you want to study with, and then they would encourage you or not to apply for that program. So if nothing else, it helps to whittle down the different programs that you would apply to. And I guess if I were getting an email from someone to do something science related in my lab, but they have a background in the not sciences, I wouldn't just push that email aside right away. I think you can pitch that in a way that it's a strength. And for me, if the person seemed like they were thoughtful and articulate and had sort of clear ideas maybe of how they were going to take their strengths, I guess, as an artist and bring it to a scientific problem or question, I would be really excited to have a conversation with that person. And I know other faculty members at CUNY that have taken on students with backgrounds in sociology to do like very much like hard science related work. And so I think if you're going into it thinking that your background as an artist is a drawback, you can very easily convince the person you're writing to that it's a drawback depending on how you word things. But if you can go into it viewing it as an asset and a strength, then you can sort of like walk the person you're writing to into that direction as well. And so don't be afraid to reach out to people. I think most people are nice and kind and willing to write back and engage with students.
I can just also tag on to that point too. Like I am a deeply introverted, shy person, and I also have a non-traditional background. I came from a speech pathology background and then went into environmental science, and now I'm in my GIS grad program. And I just started emailing people and being like, "Can I talk to you?" And most of the time, people will email you back. Sometimes they don't, but like I've had some really, really great conversations with people that have just kind of shaped, okay, what do I actually want to do with this now? You know, like you get into this brand new program after being like in a totally different academic background. And so it's just helpful to talk to people because you don't always know like what your questions are. At least I didn't. So it's been helpful for me.
One other point, for those who are aspiring to become teachers or professors, I think it's very important that we encourage our students, because the approach that we take to speaking to students and addressing their questions and concerns is so key in whether, I mean, it's very important in whether their decision would be to continue in the sciences or in any discipline, as a matter of fact. Because I myself, you know, I'm listening to those who are making contributions, including Lindsay, who spoke earlier about being shy. I was painfully shy. And many of my friends, those who were schoolmates, they were my schoolmates at the time. Today, they're really surprised that I'm teaching because I was so shy. But it was because of the support I received from my teachers when I was in high school. But more importantly, during undergraduate studies, graduate studies, there was so much encouragement. And for students, if you show the interest and your professors can see that you are really trying, your commitment is so important, demonstrate it and you'll get the support you need. Because sometimes professors reach out to students and the students may be interested, but a little too shy. Don't allow your shyness to keep you back. It's so important. Once the professors know that you're really interested, you will get the support. So I'm encouraging on both sides. Professors support the students, and students don't back down. Don't ever. Oh, I'm sorry. I think I was muted. I was saying don't ever back down.
It's all super helpful, especially as someone who's like about to start navigating the whole grad school process and is like trying to put it off as long as possible. But I know we're a little bit over time. I can't remember, Lindsay, if you said you had a meeting to get to after the workshop, but if there aren't any additional questions, we're good to go. Definitely don't want to keep you for much longer. But I think we'll go ahead and wrap this up for today if everyone's good to go. So again, Dr. Rustad, thank you so much for being here. Really appreciate it more than you know. I know you have a lot going on. It's been really awesome and valuable to have you join these chats and talk about some more unique experiences compared to some of the other speakers before. So it's really really valuable to hear from you and your experiences and advice. Loved your presentation. Yeah, so lastly, thanks everyone for tuning in to these sessions, whether you attended from the beginning or you just attended today for the first time. Thanks for being here, for bringing some great questions and comments and conversation, and for pursuing a career in the environmental sciences in the first place. It's definitely important and relevant work, for better or for worse. So it'll be awesome to see what amazing endeavors and projects that everyone takes on in these coming years. So as a very last reminder, every workshop of this series has been recorded and either has already been or will be posted to this YouTube channel. I just dropped it in the chat. Right now, Dr. Patterson and Dr. Templer's workshops are available to watch, and last week's workshop with Sarah Garlick and today's with Dr. Rustad will hopefully be uploaded very soon. So if I'm not forgetting anything, that's all for today. Thank you all again, and stay safe.
Bye. Thanks, everyone. Have a great day.
Bye, everyone. Thank you, Lindsay. Thanks,
Thank
everyone,
you.
for joining.
Bye.